Hello, a very good morning to all students. As you know that today we are going to have a very important topic on rectifiers. As we know that very long back there were no rectifiers, that is there was no power supply to get DC signal. So we had only dry pencil cells, and as we know that when we want to play something, for example if you want to play a Walkman, then every time if the Walkman requires 3-volt battery, then we used to have 1.5-volt pencil cells of 2 quantities, and every time whenever we want to play something we are spending much more amount to it. So then the need of this power supply came into existence. So as you know that the most important device that converts the alternating signal into a direct current is this rectifier. So rectifier is a device that converts alternating signal into direct signal. So now we can get any amount of DC voltage. As we know that most of the electronic equipments nowadays depend upon DC signal rather than this AC. So the need of this power supply. So one of the most important component that is responsible for converting this AC into DC is the PN junction diode, which are readily available. So in the previous section we have already studied this PN junction diode, its basic construction, its operation and the characteristics. So with the help of these characteristics we are now able to convert AC into DC, as this device is a unidirectional device which conducts only in forward bias. Therefore rectifiers are classified into two sections. One is a half wave rectifier and second one is a full wave rectifier. So the main components of a power supply are the transformer here. As you can see in this circuit diagram, it is the symbol of this transformer. So we require a transformer, then the rectifier device made up of these diodes, then we have a filter for getting a smooth output, and finally we are having the load here. So these are the parts of a power supply, and as we know that the function of this transformer is to convert into the signals, that is step down or step up voltages are required. For example, if I want a 6-volt DC output, then as per the design of this transformer and the number of turns, we have to design in such a way that the transformer provides 6-volt AC. Then this is applied to a diode which converts AC into DC. So let us see the function of a diode, how it converts AC into DC. Now this sketch is of a full wave rectifier. So last class we have already seen a half wave rectifier that converts AC into DC. Now let us see a full wave rectifier. Now a full wave rectifier, this is without filter. You can see there is no any filter circuit used in this circuit here, only there is a load here. So a full wave rectifier is again classified into center tap full wave rectifier and a bridge rectifier. So this is a center tap rectifier. As you can see, we are using a center tap step down transformer having primary and secondary windings. At point C you can see here it is the center tap transformer. A is one end of the transformer, B is another end of the transformer, and we now require 2 diodes. So D1 and D2 are 2 PN junctions and a load is connected between them. So the basic operation is very simple here. So the moment we apply the AC signal, which is 230 volt 50 hertz standard signal, during the positive half cycle of this end of the transformer becomes positive with respect to C, and this end becomes negative with respect to C. So during this period the diode D1 becomes forward bias because the P type material of this diode is connected to positive and N is connected to negative. Similarly the other diodes P is connected to negative, which becomes a reverse bias. Hence this diode conducts, you can see here D1 conducts but D2 does not conduct, and the current starts flowing from P to N in this direction as shown by the arrow mark. So it flows from positive to negative through the resistance and completes the cycle. So this is during positive half cycle. Therefore we say that across this resistance there is an output. Same way during the next half cycle, that is negative half cycle, the terminals of A and B become interchange. D2 now conducts whereas D1 becomes reverse bias, hence current flows in this direction. You can clearly observe that the direction of the flow of current is in the same direction for both half cycles. Therefore, it is a unidirectional device. Both diodes are unidirectional here. Therefore, it is conducting. Therefore, the output of the signal that you are going to receive across the resistance or the load is a pulsating output. That is, you are going to get this type of waveform only here. So, only a pulsating DC is obtained here. Whereas, we are not going to get a perfect DC which is a straight line. Hence, in the next section, we are going to study about the filter. So, when we connect a filter, it removes the AC ripples and a smooth DC will be obtained. So, this will be studied in the next section. So, from this section, the conclusion is that diodes conduct only during one half cycle, that is when it is forward bias, and provides an output voltage which is a pulsating one. Whereas, in the next half cycle, the diode becomes a reverse bias and does not conduct. So, we are having a pulsating output in this case. So, the conclusion is that a diode is a unidirectional device. Thank you.